So this is another advantage. Once you represent your knowledge in a sort of like this manner, like this compositional, right, hierarchical, distributed manner, you can represent much more complex things, right? The representation power of your network, right, would increase with respect to the number of layers you have, and also with respect to the number of nodes in a layer, right? You can represent very complex things in this way when you represent knowledge in this way, right? And also I'm going to introduce a very interesting concept called manifold learning. As some of you may know, manifold is a sort of like a subset of any feature space, original feature space, whatever. And the assumption here is, right, the real world data would have some structure, right? That structure is captured in some manifold, right, of the original feature space, right? As an example, think about this 2 by 2, right, the grid of pixels. You can have any kind of values here for the pixel values, but all the sort of like the faces, image of faces that you see should have some sort of like a structure which is encoded in some subset of this pixel space, right? Some linear or nonlinear combinations of original pixel values, right? So that's what we learn when we train these deep nets automatically, layer by layer, right? For example, so think about in the first layer you had the pixels in the original image that I showed you. In the second layer it managed to learn some edges. The edges is some sort of like a nonlinear combination of the original features, right? Okay, so so this is again you can think of this is sort of a different representation of the same knowledge in a different space, right? So we managed to learn those things automatically, right? This is another very interesting concept called transfer learning, right? That is that, okay, now in machine learning there's a concept called generalization. That is that once you train a model with a training data set, right, it should perform well on your testing data set, right? So usually you separate out training and testing data set. You train something on the training data set, you test that, the model on the testing data set, right? If it gives you a similar or better results to the training data set, you say that, okay, the model has a high generalization capability. It's a good model, right? It's not an overfitted model, right? So in order to train a good model with a very complex network, you need a lot of data, basically. I told you that in order to represent a complex knowledge, you need a complex system. In order to train a complex system, you need a lot of data. But in some problems, right, you don't find you don't find many labeled data. For example, if I want to train a neural network to recognize images of myself, I don't have much images on the web, right? It's only a couple of images of myself, right? I don't have much labeled data of myself, right? How would you solve this problem? People started to solve this problem using something called transfer learning, which is very, very interesting. That is that, okay, in transfer learning, what people do is, right, using unsupervised learning, without using any label, using all the images that they can find on the web, they can train a system using unsupervised learning to represent the knowledge about these images, right? Then what you can do is you can get this get this net, right, and train with only the limited set of labels that you have to solve your specific problem. Because this network has already learned how to represent the features of images, right? Things like that, right? So this is a very, very interesting and powerful concept which has worked in many, many applications nowadays, right? So you can apply the variation of transfer learning to do very interesting things. For example, let's say you have sort of like a document classification problem to classify a document as a positive or negative sentiment, right? You have the label at the document level, but you don't have the label at the word or the sentence level, right? But once you've trained a deep net, right, to classify these documents at the sentence level, you can use these layers, in between layers, to identify the sentiments at the word level, also at the sentence level, right? Which is called the multi-instance learning, right? So which has many applications, like for example, if you know something like the voting rate, right, for different parties of people in a particular area, right, you can use similar techniques to infer who has voted for whom, things like that. And this is another interesting task. This is say you want to train a neural network, train yourself, also recognize yourself, but you don't have much labels, label data. What you can do is, in this case, what the people have done is they have trained a neural network, right, to recognize similar faces, right? In order to find similar faces, what they have done is they have used the videos, right? If the consequent frames of a video contains the image of a person, it should be the same person mostly, right? They use that as a positive data set, but on the in order to generate the negative data set, what they have done is, right, basically on the same image, if there are two people, it should be two distinct people, right? Can't be the same people. So they use that data as the negative data set, right? By doing that, they try to train a neural network basically to find out similar images. Then what they have to do is you can use this one to train a neural network separately with only the limited set of labels that you have to recognize yourself, because this one has already learned those features, right? The similar concept that you can find here for natural language processing actually, right? And so also people came up with some other algorithmic advances. People have started applying something called the regularization methods. This is a method to avoid overfitting when you try to train a model with your data set, right? People came up with something called dropout method to do that. And also instead of those sigmoid sort of like activation functions, people apply different kind of activation functions, and also the backpropagation, improved version of backpropagation to train these neural networks called adaptive gradient methods and things like that, right? And also that's about algorithmic advances, and also the computing, right? Especially people have been using GPU computing, because it turned out that you can represent this backpropagation as a set of matrix and vector operations, and you can use GPUs to perform these operations much better than CPUs, right? Because of that, I think NVIDIA has been working on this space for a couple of years, and they came up with different solutions, right? They have these GPUs and cluster of GPUs, and recently they came up with a chip, right? So, which you can use to train neural nets, and this is like a supercomputer to train neural nets, right, deep nets and things like that. And also they have this language called CUDA that you can use to program on GPUs, and also libraries, right, to train. And also you don't have to own these machines. You can borrow these machines, right, if you use a cluster, if you use a sort of cloud computing. And also there's other open source packages like Torch, which is mainly developed at Facebook nowadays. And the Yoshua Bengio, one of the giants of deep learning, has his own package called Theano, and there's another called Caffe. So Google also released their deep learning work for a couple of months back. It's called Google TensorFlow, right? Next, we look at some of these interesting industrial applications of deep learning, right? So one of the earlier project was something called the Google Brain project, which was started in 2011, right? So started by this famous machine learning rock star called Professor Andrew Ng at Stanford, right? And in 2012, this Google Brain was running in 16,000 CPU cores with 1 billion parameters, 1 billion neuron connections, right? The goal was to train this, show this network with YouTube videos for 2 weeks, the still frames of YouTube videos, and see what it learned by itself. So basically they use this unsupervised feature learning techniques, right? So it turned out that, right, so some of the neurons started recognizing the images of cats, that is that the image was shown the images of cats, though some neurons started firing, right? So this became a huge news, right, in around 2012, right, went in like popular media like New York Times and all, right, which gave another like a very early stage popularity to deep learning, right? So the Google didn't stop there. Basically, since 2000, they've been heavily spending on deep learning since then, right? In 2013, they hired Geoff Hinton, one of the pioneers in neural networks, and his startup called DNN Research. And in 2014, right, they acquired this UK-based machine learning company called DeepMind Technologies for an estimated sum of 650 million, right? So this is the founder of deep learning, one of the founders called Demis Hassabis. And next we look at some of the work that the Google DeepMind has been trying to do these days, right? So their goal is mainly to solve the general AI using deep learning. Especially they are using something called deep reinforcement learning. That is that they are combining reinforcement learning with deep learning to solve general AI problems, right? So their mission is, right, a couple of years back to solve intelligence and use it to solve everything else, which I thought at that stage was pretty sort of like optimistic, and they've changed it to something else now, right? Solve intelligence and use it to make the world a better place, which is more realistic, right? To try to solve everything, right? So what is deep reinforcement learning? So basically in reinforcement learning, I mentioned that you have state of the world and the agent can perform actions. So the agent can get a reward, agent can perform action on the real world and he would get a reward, right? Like so you have the game environment, you have the agent, you can play some action there, right? Then you'll get some reward. At the same time, you'll get a different state of the world, things like that, right? The goal is to maximize the score of playing the game, right? So in order to solve this kind of problems, right, they use something called deep Q networks. The Q learning is sort of like a technique that people use in reinforcement learning to find the optimal subset of sequence of actions that they had to perform to achieve that final goal. So they combine that with the deep neural networks, which is called deep Q learning, right? It's called the DQNs, right? So there's some interesting papers or applications came out during the last 2 years, right? By this technique. The first one is 2015, right? So they published in Nature paper, right? So in this Nature, in this paper, in this work, what they were trying to do is they were trying to play the classic Atari games in 1980s, right? Using these deep Q networks, basically. So the input to these Q networks were only the pixels, right, of these games and the reward value, right? What's the score, right? The neural network managed, this Q network managed to learn automatically. It has to perform some actions, what actions to perform, and what is the correct sequence or set of actions to perform to maximize the score. Everything has been learned automatically, right? So if you are interested, you can look into this video in YouTube. I don't think I have time to show it now, but a very interesting video, right? You can go into Google DeepMind channel and look it up, right? And they didn't stop there, actually. So last year, right, they published this paper, and with this system, it's called the AlphaGo, right, which is that, so they managed to train a system, right, to play the most complex board game known to human called Go, right, which is much more complex than chess, right, which has lots of combinations and things like that as the next move that you can play, right, millions of or a couple of 100,000s of combinations, right, things like that. So this AlphaGo system managed to beat the world Go champion, right, 4 out of 5 games, right, which was a very big news in like a couple of months back, right. They also applied, right, the similar techniques, right, I think recently, to reduce the data center cooling of Google by 40%, right, which is a huge savings that they made for Google. I'm pretty sure that the Google have already recovered the money they have spent on this startup, right, by this achievement. And recently they have produced something called a system called WaveNet, which converts text into sort of like a speech, which is like much more similar to how would we, right, utter things, right, compared to the existing systems of speech generation, right. And also they have a partnership with NHS UK to better diagnose diseases like cancers using deep learning, and also to reduce cost, right. And the products, deep learning products at Google, right, you may have seen that the Google search have been improved drastically over a couple of years, and the things that it would suggest is it's very, I think, much more reliable than a couple of years back, right. They used deep learning to do all those things, and the voice recognition in Google, especially voice search and so, Android voice search and things like that, and Google Translate, right? And also the image search by Google. So you can upload any image and you find the similar images using deep learning methods, right? And also recently it released this Google Allow, which is very interesting if you haven't tried it yet, right? Basically, it's just like a chat application and messenger. Instead of messaging between 2 people, you can also ask web search to participate in your messenger conversation, right? It will suggest some things for you, and also it will do this smart reply. You don't have to reply for some things. It will recognize the images automatically, and it will suggest the replies and things like for you, both for text and also the images, right? And also this is a product I think that would come in next soon. It's called the Google Home product, right? Which would have the voice recognition. It would search things for you automatically. You can ask it to search anything and play any song and things like that from the web. It would does it for you, right? And also controlling the home equipment and all. And so if you want to find out what what are those features learned by these deep neural networks trained by Google, you can go into the Google Deep Dream generator, right, and upload your own image. What it does, it will run that image through that neural network and find out all the features that are fired up, and it would overlay all those features on top of your image, right? These are some of the funny images created by, and the features learned by, right, with the general images by these networks, right? That's about Google. Then Facebook, right? They hired the other giant of convolutional nets and the deep neural networks. That's Professor Yann LeCun, right? He's the director of AI at Facebook, right? And they have a system called DeepFace, which would recognize automatically tag images in Facebook. Nowadays, you don't have to tag your own image, right? When your friend uploads your image, right, it would automatically tag your image for you, right? So that is done by the DeepFace. And they also have the text recognition system called DeepText, and image caption generation, which is very, very important, right? So they have a video showing that they can describe in image to blind people the content of the image using these caption generation technologies. And they also have this intelligent assistant called Facebook M, right, which does similar thing to Allo, I guess, right? And Microsoft, they have the Skype, which can translate text between 50 languages and voice between 7 languages, right? You can speak in English, and on the other side you will get French or German or whatever, right, on the fly. And Cortana has the same capability as the other speech recognition and intelligent assistant. And also, this is a very interesting thing that came up recently, which is called Microsoft Cognitive Services. That is that you can include AI services into your application, web services and things like that. You can upload your own image, right, as a part of your software, and it will generate here sort of like the sentiment for each phases, things like that, right? And the list goes on like that, like Apple, Baidu, Amazon, Pinterest, and also there are hundreds of startups, right, trying to use deep learning to produce different products. And also self-driving cars, right, nowadays use deep learning, right, or the internet giants and the car manufacturers use deep learning to do that, right? And NVIDIA, they recently released this one, right, this sort of like a system board, right, there you can plug that board into a car and it will make your car self-driving, sort of like that, right? I don't know how well that works, but it seems like Audi and Volvo and I think Mercedes-Benz are trying to use this technology nowadays, right? And so medical images the same, right? Siemens use deep learning to do different medical imaging, and also in robotics. Relatively, robotics is quite a hard problem to solve in machine learning compared to these separate vision and other speech recognition problems. But for example, they've been trying to use deep reinforcement learning for robots to do different tasks. In this case, they've trained a robot basically to screw a cap of a bottle, right? This is a work by UC Berkeley, and also picking things, right, and grasping things and things like that, right? Okay, so far I've seen very fantastic applications of deep learning, right? But the deep learning has mainly worked so far for the sort of like pattern recognition problems, like computer vision, speech, language, whether you have these good patterns, sort of like structural, sort of like compositional, sort of like hierarchical patterns, right? For other domains like biology, sort of like finance, marketing, that kind of stuff, it hasn't worked much so far, or either there's no any published results. Sort of like maybe the hedge funds and all the investment banks are trying out, they are making like billions, right? Who knows, right? They don't publish their results, right? And also there's another problem, that is that training these nets is sort of like a black magic at the moment, right? To get the results right by training these huge nets, right? It's sort of like only sort of a handful of people like these guys would know, right? If you want to learn more about deep learning, so these are the people to follow, right? Yann LeCun, right? He's the head of Facebook research and a professor at New York University. Geoff Hinton with Google. Yoshua Bengio is still with Montreal, right? He hasn't joined the industry yet, right? Andrew Ng with Stanford, that he's the chief scientist at Baidu, right? The Google, similar to the Google in China, right? And Nandu Freitas at Oxford, right? He's working with DeepMind at the moment. And Andre Karpathy, he was a PhD student at Stanford, I think till last year or so, right? then he runs a very, very interesting deep learning course. So there are two good deep learning courses I can recommend in YouTube. One is run by Nando Dufresne at Oxford, and the other one is Andre Karpathy and his supervisor in YouTube. And he also has a very interesting blog if you want to learn more about things. And yeah, so I'll conclude my talk with this interesting but weird picture generated by Deep Dream. And thank you very much. If you have any questions, you can shoot, or I don't know, okay, go for that.
Thank you very much, Dr. Bhattovita, sharing your knowledge and your present time. So what we'll do is, if you have questions, we'll move it to the panel discussion, since we have running out of time. So let me invite the panel members. Professor Nalin Wickramarachchi from Head of Department of Electrical Engineering and University of Moratuwa. Dr. Mayura Dayaratna, Senior Technical Lead at WSO2, and of course Senior Rukshan Bhattovita, Senior Data Scientist at Ambiat Australia. Okay, so Dr. Mayura, let me move this to a different discussion path. Now, we have been talking about cloud in all aspects, right? I mean, forget about AI or big data. Now, what is the role of cloud in area of AI and big data or machine learning?
I think there is a huge role played by cloud computing in terms of artificial intelligence and big data. Like I think especially these kind of computations, they require a lot of, huge computation power. Like, so for example, if you are training some image recognition kind of system using OpenCV kind of software, then sometimes you might use GPU power. So sometimes you might not have a GPU installed on your computer. So one way of handling that is you can go to Amazon and spawn a VM with has GPUs.
Okay.
So that is one way of doing that. So that means cloud computing has enabled people to utilize these resources so that they can apply these techniques.
Okay. Still, if you look at the big data side of this,
yes.
I mean, we are dealing with large volume of data. So how scalable will be the cloud model when it refers to the big data applications?
Well, that is kind of little bit arguable thing. I mean, like, so the cloud computing, it depends on the how you deal with the cloud. Like, there are different types of clouds, like private cloud, public cloud, and there is hybrid cloud. So if you think about the public cloud only scenario, like you spawn everything in the public cloud, you have a cluster of machines. Then basically you don't deal with this problem of internet network communication. Okay. So when you find the problem of network communication, it becomes very hard to handle, right?
Okay.
So if you think about the deep learning systems, like for example, Microsoft Research in OSDI 2014, there's a nice paper. I think I would recommend all the audience to read that. There's a paper called Deep Learning System on a system called ADAM. So they trained the system, that deep learning application, on 120 computers, exactly similar. Okay. So that kind of system you cannot, train if you don't have a high power network communication. So in that kind of applications, you can't talk about communication between private cloud and public cloud. It's only about public cloud.
Okay.
So what I'm telling you is cloud computing has a huge potential of enabling these AI related research. Okay. Because a lot of people, you might not think of buying your own compute cluster. You'd rather think of renting it. So like systems like Amazon or Google, they have their own public clusters. So I think that is something that enables people to work on this.
Okay. Okay. Thank you, Dr. Mayura. So another question I'll ask from Professor Nalin Wickramarachchi, because since you have been working in this the industry, area for last few years. Now, how would you look at the future of these techniques? Like in 5 years' time, how would you see this AI, big data, machine learning in Sri Lankan context as well as a global context?
Yeah, to answer that question, I think I will look at the past, the history, because my age is much advanced than most of you people. Because I remember how I started AI. In fact, artificial intelligence or machine intelligence has gone through many generations. many rebirths, as I say. There has been many times that the artificial intelligence or machine intelligence has been advanced as the solution to everything, just like today. And then there have been many instances where it has been declared dead, only to be reborn again. So I have seen many permutations of this artificial intelligence. So one little question I had always in mind is, when something new comes in artificial intelligence, like today deep learning is very popular. So when something new comes, is it another short-lived phenomena, or will it be a long-term solution to artificial intelligence? Of course, there is always the philosophical problem, whether we find the source of natural intelligence by these techniques, or we are just mimicking our intelligent behavior. That's the real question. Of course, we do not know the answer, but what I see today is these techniques are used by companies to actually earn profit, which proves that they are actually accomplishing some objectives. They are really working. Otherwise, people, the companies like Google don't spend millions of dollars. Unlike our time, during say 2, 3, 4 decades back, the AI was basically academic domain. Only the academics were interested in AI. But today, it's the businesses who are interested in AI. So the focus has changed from academics area to industry application. So that change basically signifies that AI is real this time, that it can be applied and it can be used. Of course, we already know that it's being used, as he very well explained. So many companies are already using AI, and of course we use AI without knowing it. That when you search Google, or when you use many products from like Facebook and so on, you are already using artificial intelligence without knowing it. And that is what the technology should be. The technology for users, technology must be transparent. You only get your work done. Okay. So if artificial intelligence works, of course you will not see the machine behind it. You will see the output, and that is what is happening today.
Okay, so how would you see in the future of AI in Sri Lanka? Next 5 to 10 years?
Well, Sri Lanka was much behind in AI a few decades back, but today, of course, there are many people, again the same reason, because many IT companies now today cannot survive without AI, because there is a big push towards the AI. So as a result, they hire AI people, and as a result, there is a demand for AI. We have seen that in our universities, there are much larger demand. Students want to learn AI techniques, machine learning techniques, deep learning techniques, because there is a demand for them.
Okay.
So that means the future shall be good.
Okay. So Mayura, one last question before, since you need to leave a little earlier. So what are the technical and the other challenge, not technical, challenges in AI area, like?
To what Professor mentioned, like one of the challenges that I see is like lot of these AI techniques and algorithms have been developed by some countries like Canada or US or maybe Germany, kind of Sweden kind of researchers. So if you think carefully, you will see that those are very special things, like those algorithms. Like if you think about deep learning, how to tune it, and if you think about the previous techniques like support vector mechanics or even boosting kind of different techniques, you have to use your mind carefully and think carefully and improve that. So it requires special knowledge, special education.
So basically what you are saying is there is no special formula, like you have to think and you have to...
Yes. So basically what I am saying is, in the Sri Lankan context, basically students, even there is a huge role, should be played by the universities as well in the curriculum, it should have some way of teaching these techniques, and basically students should be inspired of using these algorithms. It's coming from some, because it's not that you are learning this AI or these techniques just for earning a job, right? You should have a passion for implementing them.
Okay.
That's why these people, for example, deep learning, like that Professor Jeffrey Hinton. So he has been striving to get the deep learning, because I have read somewhere that somewhere in 1980s or 1990s there was one Japanese professor who did the same deep learning. He tuned a very big neural network, deep neural network, but his work was vanished in the academics. But then this Jeffrey Hinton and his team, they put lot of effort to bring it back. So likewise, it's not just a simple thing. I mean, you need to make sure you should have a passion and you should strive to bring it forward.
Okay.
So that is the message that I want to give the audience.
So you are saying it's as a challenge, is it?
Yes,
that people
it's a
doesn't
challenge.
have a passion rather than it's job focus. Is that what you are trying to
Yes,
say?
I mean it should not be a job focus.
Job focus,
in the
okay.
Sri Lankan context.
Okay.
That's what I want to tell. Like, we need to bring it to the global level. So we need to work hard on that.
Okay, so that's a great message to the audience. So, I mean, if I ask question in this way now, can't you use machine learning itself to make this process much better? I mean, rather than, seems like so we have to test this and then we have to train this, check for the errors. I mean, can't we do the machine learning itself for this process?
So the testing of these things are sort of like, for example, looking for, I'll give you an example, looking for sort of like diagnostics, looking for errors in the model after training the model. So those kind of stuff is can be sort of like subjective based on the domain that you are in, the problem that it came from, right? So because of that, trying to come up with a generic solution might not be that easy,
okay,
right, in that sense. So
what you're saying is it depends on the various
all the decision parameters that you have to tune in the pipeline,
okay,
basically. Yes.
Okay. How universities in Sri Lanka is helping this cause?
Deep learning is, of course, now in the curriculum. So it's although it's just a few years old, because there is a huge demand, there is a huge interest in the subject, because especially deep learning came at a time again when the AI community was looking for something new, because the techniques that they have been using have been sort of stagnating, because they have come to their limitations. So deep learning again opened up a new window so that the AI can progress. So yes, we are actually going in that direction.
Okay. Since there are people from audience who would like to know, learn these areas. So what are the prerequisites? So how they can start learning these techniques or new techniques?
You mean self-learning? Oh.
Yeah, self-learning or any place that they can refer to?
Well, I think you can answer that. I think he talked about that.
Yeah.
Yeah, so basically you should have sort of like the right kind of background to start learning these things, right? Or start playing with these techniques, right? Basically statistics, mathematics, and programming, right? You don't have to know everything, right? But from a statistics, something like probability theory, right? There are things like that, and also from mathematical side dimension, like linear regression at least, like optimization, right? Like functional analysis, that kind of stuff at least. Right, and programming side, right, things like playing with R or Python, right, how to do simple models and things like that. So, yeah, you can start using these tools without knowing any of those things, but I don't think that the problem is if you want to diagnose something, if when things start not working, right, then you have to go back to the drawing board, go ahead to the basics, right. So for that you should have that basic knowledge of those
what
techniques.
you're saying is, to start something you don't need many large volume of knowledge. You can start with something, and then you can, from that you can move into the next area.
Exactly. Nowadays even, right, so let's say if you haven't followed let's say mathematics or statistics at your university, right, nowadays there are tons of courses online, right, you can start learning things. For example, take a machine learning course. In the machine learning course, in the first few lectures would cover first for weeks at least would cover the sort of necessary mathematics and statistics that you should have to follow that course, and it will give you some references at least, right? Things like that. So yeah.
Session today. Okay. So thank you very much, Professor Nalin Wickramanarachchi and Dr. Bhatuvedi joining us. So there are a few giveaways. I mean gifts. I'll invite Dr. Udita Ratnayaka from University of Open University. Okay, madam. Yeah. So for token of appreciation, we have few gifts arranged for you, Dr. Rukshan. Sir. Thank you, madam.
We have a gift for our moderator, Dinesh Asanka as well. So,
okay. Thank you, madam. So there is one message from Sly. There is a second international conference on December 14th. So it will be a one-day conference, and there is a request from audience, Dr. Rukshan, to share your what do you call the you said that you will be having a workshop at University of Peradeniya. Some people will not need the details of that. So could you please share the details in Meetup or wherever? If you can send it to us, we can share it on our website. Okay. So thank you very much, audience as well as the guest as well. Thank you.